Actually, sometimes they have. In my case, they have. I like both worlds, and I will show that why. Before we go into details about open source vulnerability management during software development, is there anyone here in the room who actually deals with software development? Oh, at least one, that's good. So it's for you, basically. So before we start, I work at the firma Wolf. I want to quickly tell you what this company is about. So what we do is we build software, individual software for clients who are typically more or less well-known German companies. Apart from Rolls-Royce, that's not Germany, but they belong to BMW. In a full stack approach, and we do a lot of different things. You can see we have Internet of Things, we have smart devices, not sure they are already on there. And so what we do is we build software that runs in the cloud, that we build mobile apps that have connections via the internet. We build web apps for our customers, websites for our customers. And so security is really a big thing. We cannot just build great software with great user interfaces and with a great software architecture. It has to be secure. And well, with the love affair, sometimes it is so. When we talk to our colleagues in the company, they're not so fond of having to do with security, but they learn it actually, at least. So where do I come from? I was a software developer most of my life, actually. I worked 25 years in software development projects in different companies, starting as a developer, architect, project manager, stuff like this. Then I was responsible for the IT of our own company. And there we discovered security, that it's a real topic. First internally, so we have to make our system secure. There was no CISO, so I appointed myself, actually, being the CISO. Said, nobody does it, I'm doing it now. And then 2 years later, we did the ISO 27001 certification, where I was responsible for, sometimes with a bit of guidance of Florian Oehlmeier, which was really helpful. And there my love actually not only with software started, but with cybersecurity as well. Now we have the problem, nobody pays me anymore for developing in my position as head of cybersecurity. So I do open source projects. I worked 2 years for an OWASP flagship project, Defect Dojo. That's a vulnerability management system. We'll come to this a bit later and have some other projects, one of which we'll see later as well. And so there my love comes together. I do open source development for security tools. And why this is important, we will see actually. What we want to do, I want to quickly start is how do we actually do security testing? There are different ways of doing security testing in software development. Vulnerability management is one of them. I want to show why. Want to go into details, how does it actually work? How do we do it? What makes it successful and good? And then dive a bit into, does it actually work? Is it a really good approach? Is it viable compared to, for example, commercial tools that are available as well? Florian gave me a good idea earlier on when he, at the end of his talk, talked about MoveIt, this supply chain attack. I just checked, this was a real huge attack. There were 1,000 companies affected and 60 million data sets of personal identifiable data, which is really a lot because it was used for a lot of HR systems and huge companies like the BBC, British Airways, Heidelberg, and other stuff. So it was a huge thing. And it was actually an SQL injection, something where we think this must not happen. An SQL injection is when you build a string together in an SQL statement. You say where username or login name plus and then a string, and don't check the string. And this is actually what happened there. This such a simple thing. I think everyone in our company knows you're not allowed to do that. Even the people who start coming from university. This is what happened there, and what a huge impact. So how do we test? We can do security code reviews. We do code reviews anyway when there's a merge request or when people work together in pair programming. They review each other code for code flaws, for possible programs. Is it good code? Is it conforming to the architecture? And there they should check for security flaws as well. For example, like that. This could have been found out during a code review, that someone says, no, you cannot just do a string concatenation. But it's quite cumbersome. It depends on the experience of the people. There are documents. I checked there's an OWASP document about security code reviews. It has 220 pages. I personally haven't read it. I only saw it and say, no, this is far too much for me, sorry. And so this makes sense to do it, but you will miss problems. Then we have security functional tests. What we do with the software anyway is to write repeatable tests, unit tests, integration tests, load tests, stuff like this. And they can verify security measures as well. This is really good for like authentication, authorization, stuff like that. You can really check very well. Or if you check all the input variables, stuff like that. This can really be checked with security functional tests. You just write some tests to say if there's no user, you should get the 41043 return code, and does the user have rights, stuff like this. Works very well. You wouldn't find the SQL injection there, but checks other things, it's good. Penetration tests. Our customers sometimes do penetration tests. We as a company don't have an offer for it, but other companies have that, and so if they want to do it, we say we know other companies, or they have their own providers there anyway, but it's not very often. And when it's done for a system, it's just with an initial release or larger changes, and someone can slip through there as well. And the missing link is actually vulnerability management. So there are tools that run in the pipelines, check the code, check configuration, check other things we'll quite see, and give an automated view of the system from very different perspectives. And so, these tools would have found the SQL injection, definitely. So I say if you would do proper vulnerability management with scanning tools, this would not have happened, this attack, I would say. So how does it work in general? We'll give a quick overview and then we go into more details. So we have a developer, they write code and check it in, do a push to a source code repository like GitHub, GitLab, or other things. What happens anyway is a pipeline runs, it builds the system, it runs the tests. If all the tests are running still, it deploys the build system to another environment, like a test environment or production environment. This is what happens anyway in modern software development. And here in the pipeline, the vulnerability scanners actually run with them. They produce files with results. They come in a vulnerability management tool where the developers then can have a look at these results, do assessments, what we will see later on. Additionally, it might make sense to export the stuff into an issue tracker like Jira, because the teams have their backlog, product backlog in there anyway. And now if you have the vulnerability management, the vulnerabilities in the issue tracker, they can be prioritized, they can be in the next sprint planning, and they will be mitigated and remediated. This is the overview. So we have 5 steps now, how it actually really works and which is a good way to do vulnerability management. First, avoid vulnerabilities in the first place, because vulnerabilities that are not in the system, you don't have to manage them, you don't have to mitigate them. Less work, which is always good. How to do that? Security by design. What we tell our customers, you have to do a protection needs analysis, which I'm not sure if it's a good English word, but I never found an English word for Schutzbedarfsanalyse. always have good German words at least. What you do there is you have a look what kind of data do I have, and what would happen if confidentiality, integrity, or availability is breached. What impact would it have? Would my company go bust because when this happens, I have no customers anymore? Or when this happens, well, we get it under control quite easily with a bit of money and it's done. A threat modeling, there we have a look at the system, see who would attack me, how can they attack me, and where would they find attack points. There we get an idea of probability if I could get attacked. And from that we do a risk analysis. We multiply basically the probability and the impact, and then we know where we have huge risks. And this is really important because we can then derive security requirements from that, say, for that risk we will do this and that, and then have this in the architecture, have this in our definition of done, or write user stories for it. And then we know we're on a good way to build a secure system. Automated patch management helps really a lot. So keep all your libraries, all your Docker images to date, because vulnerabilities are found in your libraries, in your Docker base images, in the libraries that are in there anyway. And the more up to date you are, the less vulnerabilities they will have. And you're prepared. If you never do that, and then a vulnerability is found, and then you see you need to do a major upgrade from not only a minor or patch, but you have to go from version 1 to 2 of that library, and this costs time. And then you're not able to really be fast to mitigate this. And there are tools, RenovateBot, Dependabot, to do this for you. There's some work for the team, but there's a lot of automated help as well. And last, here, security champions, trained employees. So security champion is someone who is in the team. It's a developer, a tester or something like that, who works in the team and says, I care about cybersecurity and I help the team and push the team to do the right things, or push the product owner, for example. This is a concept that really helps, and I have trained programmer always helps as well, because they will avoid many pitfalls that are there anyway. Second, there are a lot of vulnerability scanners on the market, of open source vulnerability scanners. So all these tools we see here are open source. You can download from GitLab. There are many more available, and sometimes they change. I just found out yesterday that TFSec is on the way out because it will be part of Trivi. So this landscape changes all the time. So what we have is here a list of things that proven in our projects to be very useful. And so we have tools. SCA is software composition analysis. There we check libraries and base Docker images where we say what's in there. And do we know any CVEs for that, for example, or from other repositories where we find known vulnerabilities. GitHub, for example, has its own one. And there we go through the libraries that are included and check and see there's CVE this and CVE this. SAST stands for Static Application Security Testing. So these tools go through the source code. They basically read the source code, have a lot of rules, and see, oh, there's something you shouldn't do. And they would detect there's an SQL where with a string concatenation. This is what these tools do. And for application, they are typically language specific. So Bandit is for Python, ESLint for TypeScript, JavaScript. We have FindSecBugs for Java and stuff like that. SameGrep is agnostic. They do a lot of programming languages. And the same we have for SAS, for infrastructure, Chekhov, TIX, TFSec. They look at Docker files, at Terraform scripts and stuff like that, and can see, will the configuration, for example, of your cloud will have any flaws? Are there things that do not use TLS by default or stuff like this? You would find out with that. Secret detection is quite easy. Detect secrets in the code. And then we have DAS, that's dynamic application security testing, where you do tests on the system when it's running. And Prowler is a tool that actually looks in the cloud infrastructure directly in AWS mainly and checks really the running configurations there. So there's a lot of tools, and we get really a wide perspective of things. One problem with these, this can be a bit tedious, all these tools, to get them in the pipeline, because each tool will be installed differently. So for every tool, you have to read the pages on GitHub and see how this is installed, how do I download it, what parameters does it have, and it's not much fun. And so what we actually did, we provide a template and Docker GitLab templates and GitHub Actions with a Docker image that have this all included, and you have a very unified way to actually then call them in a pipeline, which I will show in a second. And next thing is they get regular updated. So when you use this, for example, this GitHub repository, you know you have always the modern version of the tool with all the features available. How does it look like in a pipeline? Pretty easy, actually. Here we have an include of that repository with the GitLab template in this case, but for GitHub Actions, it's quite similar. We have different stages in our pipeline, typically build, test, deploy. Here it's part of the test. And we just say, okay, use that, what we've just included, define a configuration file, and then it will run with every test stage. The vulnerability scanners will run. There's not more to do actually really in the pipeline, so that's pretty easy. The configuration file is very easy as well. So for every tool, like Bandit for Python scans, you have to define the scanner, obviously, and which directory it runs, a subdirectory that you want to actually check for the SAST scanners, and the report name where the actual result is written. And for example, for a check of a container image, then the target is just the image that can be downloaded from Docker Hub, for example, and the report name. And then we have an upload. That's the upload into a vulnerability management tool. So this is pretty easy, very uniform, and very fast to do. And that's all you have to do these things and to find a lot of vulnerability scare. So why do we need this vulnerability management tool? All these scanners, they write JSON files in different formats and very lengthy partially, and nobody really likes to read and understand them. If you just have these files and make these available to your developers, they will say, well, no, I don't have a look at it. I know there is something, but I don't care. So then we have actually nothing. So there are tools. I know exactly 2 tools that are available, that are open source as well, that don't cost any money. That is Defect Dojo. That program I worked for 2 years on, and then for some reasons, which I'll tell you in a second, I wrote my own tool, SecObserve, which is open source as well, and which is very focused for software development. And we've seen an API wrapper for SecObserve here, but for Defect Dojo, for example, if you want to use this tool, there are API wrappers available as well, so you get them then easy in the pipeline as well. That's the good thing. And then, so now we've checked all of our software, of all of our configuration, all of our libraries. We have all the stuff in the tool, great, and now we have actually to do the assessment, and the remediation of the vulnerabilities. We have to work with it. So these 2 tools, Defect Dojo is very mature. It's an OWASP flagship project, which is always a very good thing because OWASP said this is a really good tool. It started in 2015. I'm not completely sure. I think it has started actually earlier, but this is where they put it on GitHub. It has tons of features. I think they support like 150 vulnerability scanners and a lot of stuff for infrastructure as well. And tons of features, but they have a very complex user interface. So it's not really great to work with it if you're a security specialist and this is the tool you work with all day or every day. Then it's really good. And if you want to manage vulnerabilities really on an enterprise level, if you scan your data centers and other stuff, this is a really good tool. SecObserve is not that mature. It started this year, developed by our company, me and some colleagues. We don't have a huge history there, so it's a very modern, clean, single-page application. This was very important for us, that it really works for people who just use it from time to time. And at least the developers in our company are very picky about user interfaces. We have seen a lot of tools they don't want to use because they say, oh, it's too complicated, I don't want to do that. And this was in our mind to say we do it really in the way they want to work with. But this is focused really on software development of cloud-based systems. This is why we support only some of the scanners and not 150. And the way it's intended is it should stay this way. It should stay clean, do one job, do this really nicely. If that's not for you, Defect Dojo might be for you. So you have options. It's always great with open source. But now we will focus on SecObserve and see how to work with it. How does it actually look like? What do you actually see in such a tool? What do you get out of it? And so what we have here, first screenshot is actually, so we define a product, like here an hypothetical MCTTP app. We haven't checked the app of you here, but just an example. And one thing, what's important is here the source code repository. We need this later, so we defined where we actually have the code, because we want to then jump to the code. This is not existing. Don't try to have a look at it. It's not there. So with a product, it's always nice to have some metrics to see what happened in the past, how have things evolved, how are my severities, how many observations, vulnerabilities do I have, what is their status, so we get an overview, that's nice. And we have actually then the list of observations in here. So this is all the stuff that came in from the pipeline. We could actually, with the upload buttons and import from API, we could do this manually as well. If we're in a test phase, or we just set things up, or we use it, for example, for audits we do for customers, it's a one-time thing, can do it manually as well. And we have an export that exports it in Excel or CSV or in some other formats. Then you can work with the data for people who don't have access to the system, or make your own dashboards or stuff like this. Why are they called here observations and not vulnerability? We said we talk about vulnerability management. Here they are called observations because they're still observations. This is something a tool has said this is there. These are things a tool said, I found this. If this is a real vulnerability, we don't know yet. We have to look at them and see, are there vulnerabilities? Are we affected? What's the impact? We have to look at this. And then now I have a few examples that you get a feeling about what it is. So this is an example from a SAST, actually from source, from the composition analysis. So here we found an issue. We see we use Python Django as a framework in the version 4.02, and this has an issue with some actually an SQL injection in there. And so we see a lot of things here. We see the description, we see a recommendation, upgrade to Django to version 4.04. We see vulnerability, what comes out of the CVE database with all the information. Does anyone know the EPSS score? Florian, do you know it? Have you ever heard EPSS? No. That's a score that I found that can be downloaded that shall say something about the impact. I'm not still completely sure if it's helpful. We see the component with the Perl and stuff like this. And on the right side, we have then some metadata about it. So our product name, the parser. So the parser name is the actual format. And the format is really good, why we can support some tools. We use very extensively two formats. One is cyclinDX, the SBOM format, because tools like Trivi, Gripe, they write SBOMs. and they write the vulnerabilities in the SBOM. And this we can read here. And so every program that can write an SBOM with vulnerabilities, we can import here, which is a really good thing. And then if we do this, we get an SBOM with it anyway, which we always, is a helpful thing. And so you see the actual scanner references that help us to see what's really going on if the description is not good enough. So we get really a lot of information with it. And this all comes out of the scanner. So this is all what such a scanner like Trivi in this example really writes, and so you get a really lot of information. Another example, this is now a SAST, where we use another format. You can see it in the parser name Sarif. That's a format for results of static analysis. It's used by GitHub as well, and so basically every SAST tool can write the Sarif format. So I didn't have to write lots of parsers, but I have one parser that can read the Sarif JSON, and every tool that supports Sarif can be imported here. Great thing. Standardization helps. And here again, we have a description. We have even a snippet of the code in here. There we can see why is MD5 used, but there we see the source file here as origin is a link, and so we could click on it, go to GitHub. We would really have line 83 highlighted and see what's going on there, what is the context, what does it mean for us. We get the references again, and we haven't seen it before. We have evidences. This is part of the of the JSON that we read that is relevant for this observation, and then we can have a look in this as well if there's not too much information here. So we get a lot of information. And it's all in a very similar way. Another example for infrastructure as code from the Kix tool, where we then have, for example, a problem in the Docker Compose file. So then we get a really quick overview of what's happening and if this is relevant or not. We see the severity that comes out of the tool, the status, it's open, so it's there. Or a bit different is, for example, this here, because this is there we use a tool Cryptolyzer to actually check the SSL configuration of the server, of the running system. This is now dynamic. Here we did it a bit differently because we just showing the SSL configuration is not really helpful. But we check it against the BSI standard for SSL, the current standard, and say, okay, there could come out like TLS 1.0 or 1.1 is still used. It's an observation. Or here, there's one cipher suite that's not according to the BSI recommendation. If that's really a problem, up to you to decide. So how do you work with it? You have to eliminate undesired results. So it can be false positive things the tools tell you, but they're not actually right. For example, the Git leak scanner who scans for secrets, so if he finds a tenant ID with this UUID format, he says, oh, this looks a bit like a secret. It's not, it's a tenant ID or the client ID. They tend to find false positives in the code as well. Or you say, I'm really not really affected by that because it's only a development system and it's only internal. I say, no, I don't care about this at the moment, or it's not security rated, it's there, but it's maybe just a bad code practice. So you should eliminate these by, you could change the configuration. That would be the best thing of your scanner. Say, don't include the tests files, for example. You can do a manual assessment, which I will show with the tool. Say, no, this is not really relevant for me. Or I think Defect Dojo has it as well, and SecObserve has it. You can be rule-based. You can say everything that's in the test directory, forget about it, we don't care. Or everything that has something with dev in the end in the title, don't actually look at it. And so you get a much smaller list. Still some things in there. Now you do a risk acceptance. You can say, okay, there are things in here which I don't want to deal with it because I know there's a risk, with this observation, but still with my risk analysis I've done before, I say I can deal with it for now, it's fine. So this you could always then mark in the tool and say, yes, the risk is accepted with a reason for it, then it's documented, which is always good. If something happens later, you have kind of a documentation, yes, I did this on purpose, if someone asks. And the rest are actual vulnerabilities. These are then the issues you should solve. So this should then, for example, go into the issue tracker, and they need to be fixed. And the good thing is they get fixed. The pipeline runs again. They don't find this vulnerability anymore in this observation. And then SecObserve and Defect Dojo would do the same, say, okay, this is not in there. This is resolved. It's still in the system. It doesn't get deleted. You can see there it was found, and then it was marked as resolved, so you don't see this anymore. And so then the idea is the list gets smaller and smaller, and is always manageable. This is then the workflow things you have to do, the developers or some security experts who help them. How does it look like? As an example, here we have a thing where it says the system could be bound to all interfaces, which might be a problem, but what we actually see, it's a development setting. So we see it's a setting for development, and we know there's a production setting as well, and this has not been marked. So we say, okay, it's not affected. We give a reason, it's only a development system, press save, and then we see two things. The status has been set to not affected, and the log entry is there where it says it's Stefan Fleckenstein has decided it's not affected on that day with that reason. Still some kind of documentation why things are there. And now in the list of open observations, not there anymore. Same we could do with the severity, say, oh no, that's not severe, that's not medium, that's only low, or no, that's for us not medium. We override the tool and say, for us that's really critical. This could be some kind of assessment there as well. So this is how it works. So you see it's pretty easy to set up, to run. You get a good support, and then your work starts, basically. But this is what it is about. Does it actually really work? Do we get good results of all these open source tools? So we had to look at this. We had a student in our company. What he did, he worked with 3 of our projects, of our software development projects. They had the scanners running, and then evaluated some security experts and developers of the project, said, okay, we have a look at the results and check, do they make actually sense in this example? So the first thing they did, they checked false positive and found, yeah, Git leaks, because of tenant IDs and stuff like this, there are quite an amount of false positive. From other tools, not so many. I have to say, here I was a bit surprised about the results when I saw them, because I would have expected a bit higher amount of false positive in the SaaS tools like Bandit or what else did they use? SemGrep, for example. I would have expected it a little bit higher, but maybe they had a good configuration before of that. But pretty good result. This is something you can deal with. You have not too many things that are not interesting. Next thing is severity. So is the severity good? Are things really relevant? What we found is the critical and high severity seem to be pretty good. It's for the critical, it's the same amount. So everything what's the tool said critical, the expert said critical as well. Not so much when you look at higher info or low things. So I think they must have a configuration problem, because lots of what the low severity seems to have gone to info in the idea of the developers. Are they the same that we see in this table here? We see all the critical, so the tool in the row said it's a critical thing, and all the developers said, yes, all of them are critical. It's still a good coincidence of the high things and not so much in the lower things. But And the high-end critical are the important ones. So we get a really good detection of these with our open source tools. Why is that so? Open source tools, the scanners, are actually often the basis of commercial tools, like Kix, the scanner for the SaaS tool for infrastructure. It comes from Checkmarx. They just set it open source, or some other tools are from commercial companies that build the other systems with that, but the base tool is actually what they use as well. So these are, or they are well-respected communities like SamGrab who have a lot of people. And the good thing is, it can be introduced faster. Commercial tools often are like 50 to 100 euros per developer per month. This is a lot of money, so you want to do a proper vendor selection. You will have to deal with procurement processes, and the project says we need something now. With open source, they can just start whenever they want. On the other hand, commercial products, they have better support, often for fixing the vulnerabilities. We had some support here. The commercial tools we've seen have more information and say do this and do this, can help. And what I actually think is AI might be a game changer for commercial tools in the future, because, and I've seen that tool developers are working on that to give an advantage how to find vulnerabilities, to be more exact. And then helping to fix this. I mean, GitHub can always do it. It helps us coding, and we all coders use it. And now the tool might actually does it for me, so I don't have to think of it anymore. Say the tool, yeah, just fix it if you found it, fine. And I'm not sure we will see this in the open source tool that fast. Yeah, and summary of it all, do these 5 steps and do it. The results make sense. It's easy. It works. And it needs to be done, because otherwise you will have something like MoveIt, what you don't want to have, actually. I'll tell you later, Florian, why. That's it. Thank you very much.